In section 5.2, we look at the sum and difference formulas. So we start this section with a question. Is it true that the sine of A plus B is the sine of A plus the sine of B? So if you believe this, then you believe that what we're doing here is we are distributing the sine to both of those. Well, it turns out that this is not true. And I'm going to show you why. All we have to do is pick a couple of values for A and B. So let A be equal to 30 degrees and B be equal to 60 degrees. The sine of A plus B would then be the sine of 30 plus 60. And we know this is the sine of 90 degrees, and the sine of 90 degrees is 1. If we use the right-hand side, then what we would have is the sine of 30 degrees plus the sine of 60 degrees. Well, the sine of 30 degrees is 1/2, and the sine of 60 degrees is the square root of 3 over 2. And this is equal to 1 plus radical 3 divided by 2. And these two values are not equal. So it turns out that this is not true. So the question is, what is the sine of A plus B? Is there a formula that allows us to compute this expression? And the answer is yes. And in the next couple of minutes here, I'm going to be showing you where these formulas come from. So we start on the unit circle. And we'll notice that this angle here is angle A, and then angle B is drawn from angle A over to here. So this is angle B, and that makes this entire angle here A plus B. And then we also draw the angle negative B in standard position. And the idea is that the angle here is A plus B in size, and the angle here is A plus B in size. So because that is true, then we know that the chords formed by those angles, so here is a chord that corresponds to the angle A plus B here, right? This is the chord from point P1 to point P3. And the other chord goes from here to here. And that chord also comes from an angle whose size is A plus B. So this chord from P1 to P3 has the same length as the chord from P2 to P4. Now, what about the points? Well, we know that the point P3 is the point 1, 0, again, because we are on the unit circle. The point P1 is going to be the cosine and the sine of the angle in question there. Well, the angle in standard position to this point is the angle A plus B. So the x-coordinate is the cosine of A plus B, and the y-coordinate is the sine of A plus B. Likewise, this angle here is angle A, and so this point has coordinates cosine of A and sine of A. And then this point down here comes from the angle negative B, and so its coordinates are the cosine of negative B and the sine of negative B. But because cosine is an even function, we can rewrite that as the cosine of B. And since sine is an odd function, we can rewrite this as negative sine of B. Okay, so the main idea here is that the distance between the points P1 and P3 is equal to the distance between P2 and P4. And so we'll represent this symbolically as P1, P3 equals P2, P4. So this says the distance between these 2 points is equal to the distance between these 2 points. Now the question is, how do you find the distance? So let's remind ourselves of the distance formula. Suppose you have 2 points, we'll call one of the points x2, y2, and the other point x1, y1. To find the distance between these 2 points, we take the square root of the difference between the x-coordinates squared plus the difference between the y-coordinates squared. So we're going to apply this formula to the points here, right? These coordinates and these coordinates. So we're going to find the distance between those two, and then we'll find the distance between these coordinates. So the distance between P1 and P3 is going to be a big square root, and we're going to be subtracting the x-coordinate here and the x-coordinate here. So that gives us the cosine of a plus b minus 1 quantity squared, plus, and then we are going to subtract the y-coordinate here and the y-coordinate here. And so that is the sine of a plus b minus 0 quantity squared. And then we'll find the distance between P2 and P4 by doing the same thing. So again, a big square root. And we are going to subtract the x-coordinate here and the x-coordinate here. So that is the cosine of A minus the cosine of B quantity squared. Plus, and then we do the same thing with the y-coordinates. So sine of A minus negative sine of B quantity squared, right? So notice that there is a negative in front of the sign there. All right, now from here, we are just going to set these two things equal to each other. But here's a little trick that we can apply. If you know that the square root of some number m is equal to the square root of some number n, then this must mean that m is equal to n, right? That's a simple property from algebra. So if this big square root here is equal to this big square root here, then whatever is inside of this thing must be equal to whatever is inside of this thing. So I'm going to take the inside of each one of these radicals and set them equal to each other. And just take note of the fact that the sine of a plus b minus 0 is the sine of a plus b, right? So we don't have to write the minus 0 there. And also, when you subtract a negative here, that becomes a positive. So in the next step, what I'm going to do is multiply this out. So we need to FOIL this, and we need to FOIL this, and also FOIL this. And then here, we're just squaring the sign. So this one's relatively simple. So let's go ahead and FOIL all those and see what we get. All right, so we did all that multiplication. And if you need to, go ahead and pause the video and verify this multiplication for yourself. But I want you to notice what we have now. We have cosine squared of a plus b plus sine squared of a plus b. Remember, cosine squared plus sine squared, as long as the angles are the same, is always equal to 1. So this equals 1, and then plus another 1 there is going to give us 2. And then we have minus 2 cosine of a plus b. On the other side, we have cosine squared of a plus sine squared of a. That's equal to 1. And then we have cosine squared of b plus sine squared of b. That's also equal to 1. And again, 1 plus 1 is equal to 2. So we have a 2 on the other side. And then what we have left over there is this term and this term. So we have minus 2 cosine A cosine B plus 2 sine A sine B. Now what we can do is subtract 2 from both sides of the equation, which will cancel out the 2's. And then what we have is negative 2 cosine of A plus B is equal to negative 2 cosine of A cosine of B plus 2 sine of A sine of B. And the last step to figure out what cosine of A plus B is simply to divide both sides by negative 2. On the left side, these will cancel out, which will leave us with the cosine of a plus b. And on the right side, the negative 2 cancels with the negative 2 here, which gives us the cosine of a cosine of b. And then for the second term, the positive 2 divided by the negative 2 gives us a negative 1 here. So we get minus and then sine of a, sine of b. And this gives us our first difference formula, or actually it's a sum formula for cosine. So it's not terribly important that you memorize the process here, but I did want to show you where this formula comes from rather than just giving you the formula. Now, we have a formula for the sine of a plus b. We have a formula for the tangent of a plus b. We also have a formula for the sine of a minus b and the cosine of a minus b, and also the tangent of a minus b. And all of these formulas can be derived fairly easily once you have this formula, but I am going to skip the derivation of the rest of the formulas, and I'm just going to give them to you on the next page. And so here are your sum and difference formulas for sine, cosine, and tangent. And I'll just point out that this is the one that we just derived on the previous page, but you have 6 formulas here. You do need to memorize these formulas, and I know it seems a little bit daunting, but I want you to notice that the formulas are actually very similar, right? So if you look at the formula for cosine of a minus b, you'll notice that the formulas for cosine of a plus b and cosine of a minus b are exactly the same, except for here you have a positive and here you have a negative, and over here you have a negative and here you have a positive. But every other aspect of the formula is identical. Also, if you look at the formulas for the sine of a plus b and the sine of a minus b, you'll notice the same thing. These formulas are exactly the same, except that here you have a positive and a negative, and here you have a positive and a negative. So what you need to memorize is just the format of these formulas. And then now for tangent, tangent's a little bit different. Tangent of a plus b and tangent of a minus b involves a fraction. But once again, if you look at these two formulas here, they are very similar. The only difference is you have a positive here and a negative here. And then in the first formula, you have a positive on top and a negative in the bottom. And in the second formula, you have a negative on top and a positive in the bottom. So the bottom line is you need to memorize these formulas, and it just takes a little bit of studying. And all I can tell you is that many, many thousands of students before you have memorized these formulas just fine. So with a little bit of studying, you will memorize them as well. Okay, let's take a look at the examples we have. So for the first example, they want us to find the exact value for the cosine of 75 degrees. And let's keep in mind that 75 degrees is not a special angle. So normally what you would do here when finding the cosine of 75 degrees is you would just plug this into your calculator. However, we can now find the exact value by simply thinking of 75 degrees as being 30 degrees plus 45 degrees. So what I'm doing is I'm expressing 75 degrees as the sum of two special angles. So you see what we have now? We have the cosine of one angle plus another angle. So we should be looking at this formula. So for us, the value of A is 30 degrees and the value of B is 45 degrees. So we are going to use the cosine of A plus B is equal to cosine A, cosine B minus sine A, sine B, with A equals 30 and B equals 45. And so if we plug that into the formula, we get the following. And from here, we can finish this by simply filling in the values for each one of these. So we know the cosine of 30 degrees is the square root of 3 over 2. We know the cosine of 45 degrees is the square root of 2 over 2. When we have minus, sine of 30 is 1/2, and the sine of 45 is radical 2 over 2. And now we can go ahead and multiply these straight across, right? So radical 3 times radical 2 is radical 6. And in the denominator, we have 2 times 2, which is 4, minus, and then for the second one, we multiply straight across. 1 times radical 2 is radical 2. And once again, 2 times 2 is equal to 4. And notice that you have a common denominator, so we can write these together as the square root of 6 minus the square root of 2 divided by 4. And this is the exact value of the cosine of 75 degrees. So it's just kind of cool that you can get an exact value for an angle that is actually not special by expressing it as the sum of two special angles. In our next example, they ask us to show that the cosine of x plus 2 pi is equal to the cosine of x. And we know this instinctively because we know that the period of the cosine function is 2 pi. So if you have an angle x, when you add 2 pi to it, the cosine of that angle should be the same as the cosine of the angle x, right? Now, to do this, we're just going to apply the same formula that we applied above, right? We have the cosine of the sum of two things. So for this problem, our a value is x and our b value is 2 pi. And so we know that the cosine of x plus 2 pi is equal to the cosine of x times the cosine of 2 pi minus the sine of x times the sine of 2 pi. And so again, I'm just using this formula. But we can simplify this because we know that the cosine of 2 pi is equal to 1. And we know that the sine of 2 pi is equal to 0, right? Those are values that we should have memorized. And then finally, we have the cosine of x times 1, which is the cosine of x, minus, and then here we have sine of x times 0, which is 0. And cosine of x minus 0 is cosine of x. So I have proven that the cosine of x plus 2 pi is equal to the cosine of x. In the next example, they ask us to write the expression cosine 3x cosine 2x minus sine 3x sine 2x as a single cosine. And at first, I think this problem can be kind of confusing. But if we bring in the appropriate formula, I think we'll be able to see rather easily what we should do. So here is the sum formula for cosine. And you can see that it matches up perfectly with what they've given us here, right? Cosine of 3x is represented by cosine of a, so a would be 3x. Cosine of 2x is represented by b, so b would be 2x. And then notice that the same thing follows over here, right? A is 3x and b is 2x. And so according to this formula, this expression up here would be equal to the cosine of a plus b. Well, again, a is 3x and b is 2x. So we just have 3x plus 2x, and of course, this is the cosine of 5x. So the problem is not terribly difficult once you recognize that you just need to use this formula. And of course, you have to identify the values of a and b, right? So we have to recognize that a is 3x and b is 2x, and then you're just substituting those values of a and b into the formula. In the next example, they want us to show that the cosine of 90 degrees minus a is equal to the sine of a. And we actually showed this a long time ago when we talked about the co-function theorem. Remember, back in, I think it was chapter 2, we talked about how if an angle is a complement with another angle, that the sine and cosine of those angles are the same. Well, now we can prove it by just using the appropriate formula. So here is the formula for reference. Notice that we have the cosine of the difference between two angles. So that's what we have here. And according to the formula, it says the cosine of a minus b is the cosine of a times the cosine of b plus the sine of a times the sine of b. Now, this can be a little bit confusing because you'll notice that they have the letter a here, and we have the letter a here, so that could be kind of confusing. So instead of thinking of a's and b's, sometimes it's better just to think of a as the first angle and b is the second angle, right? And so what this is saying is the cosine of one angle minus another is the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. So in our problem, the first angle is 90 degrees, right? Because that's the one you see first. And the second angle is A. So if I apply the formula here, this is going to be equal to the cosine of the first angle times the cosine of the, cosine of the second angle plus the sine of the first angle times the sine of the second angle. And then we can finish this because we know the cosine of 90 degrees is 0. So we have 0 times the cosine of A plus, and then the sine of 90 degrees we know is 1. And so we have 1 times the sine of A. Well, 0 times cosine of A is 0, and 1 times sine of A is sine of A, and 0 plus sine of A is sine of A. And that's what we were trying to prove. So again, I recognize that, this can be a little confusing since the letters here are a little bit switched around. But hopefully if you think of it as first angle, second angle, that can help with that. And you can also put in your own letters here, right? So you don't have to use A and B, you could switch it up. For example, like this. So what I've done here is I just replaced A with the letter X and B with the letter Y, and you'll notice it's the same formula, but it has X's and Y's. And so if you were to apply that formula, you can just think of X is 90 degrees and Y is the angle A, right? That's your X and your Y. And then it's a little bit easier to just plug it into the formula. But again, I don't think you should really have to use the formula in a different format, right? As long as you think of first angle and second angle, I think that's the way to go. In the next example, we are asked to find the sine of the angle pi over 12. And so the challenge here is that you have an angle in radians, and we don't always think as well when we have an angle in radians. So how do we express pi over 12? Well, what I'm going to do is I'm going to express it as pi over 3 minus pi over 4. And you'll notice that if you do pi over 3 minus pi over 4, you would need to get a common denominator by multiplying this fraction by 4 and this fraction by 3. And doing that gives you 4 pi over 12 minus 3 pi over 12. And 4 pi minus 3 pi is 1 pi over 12. Now, I have a lot of experience in doing this, and so figuring out what two fractions I need to subtract to get pi over 12 is not that challenging for me, but I think that for most students who are first learning this, this can be really challenging. Now, I'm going to go ahead and finish this problem, and then I'll show you another way to approach it. So from here, you would just use the appropriate formula, right? And the formula would be the sine of an angle minus an angle. So we'll go ahead and bring in that formula. And so according to this formula, the angle A would be pi over 3, and the angle B would be pi over 4. Or again, you can think of first angle as pi over 3, second angle is pi over 4. And the formula says you take the sine of the first angle multiplied by the cosine of the second angle minus, and then the sine of the second angle multiplied by the cosine of the first angle. And then from here, we just have to fill in the values. So the sine of pi over 3 is radical 3 over 2. cosine of pi over 4 is radical 2 over 2 minus sine of pi over 4 is radical 2 over 2, and the cosine of pi over 3 is 1/2, and this is square root of 6 over 4 minus square root of 2 over 2, which is the square root of 6 minus the square root of 2 over 4. And I apologize, this should be a 4 right here, right? Because 2 times 2 is 4. So that's my fault. There we go. And you'll notice that this is the same answer that we got a little earlier. And we'll talk about that in just a minute. But let me show you another way to approach this problem. So another way to do this would be to just take the angle pi over 12 and change it to degrees. So if we multiply this by 180 degrees over pi, the pi's will cancel out and we get 180 divided by 12, which is 15 degrees. So that means the sine of pi over 12 radians is the same as the sine of 15 degrees. And then from here, you see, you just have to figure out how can you get 15 by adding or subtracting two special angles? Well, you actually have a couple of options. One way to do it is 60 degrees, take away 45 degrees. That's basically what I did up here. But you also could say 45 degrees minus 30 degrees, right? So either one of these would work. But the point is, it's just much easier to find out what to subtract to get 15 than it is to figure out what to subtract to get pi over 12. So this is another approach. And if we go ahead and continue with this, we will have the sine of the first angle times the cosine of the second angle plus the sine of the second angle times the cosine of the first angle. And if we fill in those values, sine of 60 is radical 3 over 2, cosine of 45 is radical 2 over 2, etc. And of course, we are getting exactly the same thing that we got up here. And this is, when completely simplified, the square root of 6 plus the square root of 2 divided by 4. So same answer. All right, so now I want to comment on why is this answer the same as the answer we got in the first example. So remember, in the first example, we did the cosine of 75 degrees, and we found it to be the square root of 6 plus the square root of 2 divided by 4. And now we're saying the sine of 15 degrees is also the square root of 6 plus the square root of 2 divided by 4. So these are the same. But why? Think about it for a minute. These are the same because 75 degrees and 15 degrees are complementary angles, right? In other words, if you add those together, you get 90 degrees. And we know that sine and cosine are cofunctions. And so the cofunction theorem tells us that sine and cosine of complementary angles should always equal the same value, okay? So it's not surprising after all that these are the same. In our next example, we are asked to find the sine of a plus b and the cosine of a plus b and the tangent of a plus b when given the following information. So sine of a equals 3/5, and a is in the first quadrant. Cosine of b is negative 5/13, and b is in the third quadrant. And using that information, we have to figure these things out. So what I like to do here is go ahead and bring in all the formulas for each one of these. So let's bring those in. So here are the formulas for sine, cosine, and tangent of a plus b. And you'll see that in order to figure these out, we need to know the sine of a, the cosine of a, and the tangent of a. And we also need to know the sine of b, the cosine of b, and the tangent of b. So what we're going to do is go back to the beginning where they gave us information about angle A and information about angle B. And what I'm going to do is draw a picture of each one of those angles in their respective quadrants so that I can figure out the information that we need to finish this. So for angle A, we know that angle A is in the first quadrant. So if I draw a picture of that, the picture would look something like this. So this is angle A. And we know that the sine of angle A is 3 over 5, which means the opposite side would be 3 and the hypotenuse would be 5. And because this is a special triangle, it's the 3, 4, 5 right triangle, we know that the missing side here would be 4. And then we'll go ahead and draw a picture of angle B. Angle B is in the third quadrant. So angle B looks something like this. And we know that for angle B, the cosine is negative 5 over 13. And cosine is the adjacent side over the hypotenuse. So that means this side is negative 5 and this side is 13. Now, you can find the missing side here by using the Pythagorean theorem. I'm going to tell you that this side is negative 12 because this is also a special triangle. It's the 5, 12, 13 right triangle, which we have seen several times now. And since we're in the third quadrant, we know that that side has to be negative. Now, once we have these pictures, we can now very easily write down what is the sine of A, what is the cosine of A, and what is the tangent of A, just by looking at this triangle and using SOHCAHTOA, right? So sine of A is 3/5, cosine of A is 4/5, and the tangent of A is 3/4. And then we could do the same thing for angle B. We could find the sine of B, the cosine of B, and the tangent of B. Sine of B is negative 12 over 13. Cosine of B is negative 5 over 13. And tangent of B is negative 12 over negative 5, which reduces to 12 over 5. And now we're just going to take those values and plug them in to each one of these formulas, and then we will have the sine, cosine, and tangent of A plus B. So let's go ahead and do that. Okay, so I have taken the liberty to substitute all the values you see over here into the respective spots in each one of these formulas. So you might want to pause here just to make sure that I've done all that correctly. Now to find the values, all we have to do is perform the multiplication here. So 3/5 times negative 5 over 13. Normally you would cross cancel here, but I'm not going to cross cancel because I want to keep the common denominator. So this is negative 15 over 65. Plus, and then here we have negative 48 over 65. And so this is equal to negative 63 over 65. And for the next one, if I do the math here, we have negative 20 over 65 minus, and then we have negative 36 over 65. And the minus minus here becomes a plus, and that gives us positive 16 over 65. And finally, for the tangent of A plus B, this is a little bit different because we have some fractions here. We have 3/4 plus 12/5. In the denominator, I have 1 minus, and I'm going to go ahead and cancel here. So 4 goes into 12 3 times. So what I have left over there is 3 times 3 is 9 over 5. And then from here, there's a couple of different ways to do it, but what I like to do is multiply the top and bottom by the least common denominator, which is 20. And that 20 gets distributed to everything like this. And if we do the math there, we have 20 times 3/4, which is 15, plus 20 times 12 over 5. Well, 20 divided by 5 is 4, times 12 is 48. And in the denominator, we have 20 times 1, which is 20, minus, and then here we have 20 divided by 5 is 4 times 9 is 36. And so we have 63 divided by negative 16, which is the same as negative 63 over 16. So we now have the values for sine of a plus b, cosine of a plus b, and the tangent of a plus b. And there is one last thing you can do to kind of check to make sure that you have the right answer. And this is really cool, so I'm going to show you this. So to check to make sure that you got all this right, I'm going to remind you that the tangent of a plus b is actually the same as the sine of a plus b divided by the cosine of a plus b, right? That's our ratio identity. And we know that the sine of a plus b is this value, and the cosine of a plus b is this value. And this is equal to negative 63 over 65 multiplied by 65 over 16. And then notice that the 65s cancel out, and that gives you negative 63 over 16. So this is an alternate way to compute the tangent of a plus b without having to use this formula, right? But what I like to do is go ahead and use all three formulas, and then when I get the value for tangent here, I'm going to do the tangent the other way to make sure I get the same value. If these are the same, there's a really high percentage chance that you've done everything correctly. So this is a great way to check. In our last example, they ask us to graph the function y equals 4 sine of 6x cosine of 4x minus 4 cosine of 6x sine of 4x from x equals 0 to 2 pi. So this is seemingly very strange, but let me show you that you can rewrite the function y by factoring out the common factor of 4 here. And if you do this, you get the sine of 6x cosine of 4x minus, and then I'm also going to switch these around. So instead of saying the cosine of 6x sine of 4x, let me just say sine of 4x cosine of 6x. Same thing. And then what I want you to notice is that this should look very familiar. This is one of these formulas over here. So all we have to do is identify which formula is it. So notice the format. It goes sine, cosine, sine, cosine. So it has to be one of the first two, right? And then, of course, we have a negative here. And so you have to identify the negative that you have here. And so the formula that we're going to use to help us simplify this problem is the sine of a minus b formula. So what you have here is the sine of a cosine of b minus the sine of b cosine of a. So we're going to use that formula with a equals 6x and b equals 4x. And when we do that, we're going to have the sine of 6x minus 4x, which of course is the sine of 2x. So I can simplify this function by writing it as 4 times the sine of 2x, right? So all of this is equal to the sine of 2x. So now it's not so difficult a problem. They are asking us to graph this function. Well, this is a sine function where the amplitude is equal to 4 and the period is equal to pi, right? Because the period is 2 pi divided by 2, right? There is no phase shift. There is no vertical translation. So we are just graphing this sine function. So from 0 to pi, we will have one period for this graph. So it will start here. It will end here. And we know that sine starts at the origin. It also ends at that level, and halfway in between is at that level. And then it will reach a high point of 4 here and a low point of negative 4 here. So this is what the graph looks like. So it really just turns out to be a review of some of the graphing that we did previously. But they did ask us to graph between 0 and 2 pi. I'm going to go ahead and extend the graph for the entire axis that you see here. And here is what that graph will look like when you extend it. This is extending it from negative 3 pi all the way to positive 3 pi.